Good morning to all. I am Umasankar, Associate Professor, EEE Department, S.A. Engineering College. Today I am going to explain about GATE coaching for electrical engineering students. So previous class we discussed already star delta transformation. So today I will explore about RLC elements. Okay. So in this example problem, if energy stored in the capacitors C1 and C2 are same, then what is the value of C1 divided by C2? Okay. So before going to this problem, first of all, we know very well what is the use of capacitor. Clear? So capacitor can be used for energy storage, and in electronics, tuning, filtering, power factor correction, voltage stabilization. So this is the application of capacitor. Different type of capacitors are available. So electrolyte capacitor, film capacitor, mica capacitor, tantalum capacitor. So various capacitors are available. Okay. So energy storage, normally the capacitor stores the energy in the electric field. If you are giving a supply to this capacitor, the capacitor starts to charge up to the voltage level is equal to the supply voltage. Clear? It holds the charge for longer period. Suppose if the supply voltage is disconnected, it immediately delivers the energy to the circuit. Clear? Tuning. In audio electronics or otherwise in radio telecommunication circuit, the capacitor can be tuned for particular frequency. Okay, so either can reject the frequency or select the particular frequency, the capacitor can be used. And filtering purpose, to get a smooth output, the capacitor can be used. It removes the ripple component from the voltage as well as remove the noise in the signal analysis also. And power factor correction. In power system, we know very well the pure capacitor provide a leading current and inductor provide lagging current. Okay. In all the industries, right, 99% inductive nature equipment only used. That is, for example, in all the industries, three-phase induction motor they are using, that is 99% inductive type nature. Okay, so all the components produce only lagging power factor. So to improve the power factor, we can use the capacitor bank. So you know very well, for example, the voltage is the reference. We can consider the voltage is the reference. The inductive nature equipment produce lagging current, okay, I suffix L. So this produce phi L. For example, if you are connecting a capacitor bank, it produces leading current. Okay, so this is IL. sorry, IC. This is IC. So the resultant component of the current this is the resultant current. So the power factor value is also improved. Why? Because the angle difference between the voltage and current is increased. Clear? Suppose if the phi value is 0 degree, the cos phi equal to cos 0 equal to 1. So suppose if phi equal to 60 degree, okay, the cos 60 equal to 0.5. So when the angle increase, the power factor is keep on decreasing. Okay, so the idea is if you are adding the capacitor bank, the power factor is increased, the meaning is nothing but the angle is also decreased. The meaning is nothing but the deflection between the voltage and current is decreasing. So this is the advantage of the capacitor. Similarly, voltage stabilization in the power grid is also, suppose due to any unwanted fault occurs in the transmission line or load increase, that will affect the voltage. So in this stage we are using a different type of fact devices. The fact devices consist of the main component is nothing but capacitor. The capacitor injecting the reactive power. So based on that, the voltage is slightly improved because Q is directly proportional to V. So this is the application of capacitor. Okay. So now you know the importance of capacitor, right? So okay, in this problem, how to find the ratio of C1 divided by C2? Clear? So first, modify the given circuit. First I can modify the given circuit. So this is the given circuit, right? So 2R, this is R, C2, C1, both the batteries are same, E. Okay, so first assign the name for each and every tip of this triangle. A, B, C, D. Clear? For understanding, I can modify the given circuit. So A to B, 2R is available. The A point consists of 3 lines. Okay, so I can differentiate this. This is A1. We can consider this is A1. So, and B to C, battery is available. Okay, this is A1. A1 to C, one more resistance. This is R. One more resistance R is available. This is E. Okay. Next, one more line connected to the D. Between A and D, C2 capacitor is available. So I can consider this point is C. Okay. So C2D, C1 capacitor is available. So this point is D. Okay, so between D and A, another capacitor is available. So I can consider this is A2 point because the tip A consists of 3 lines. So I can differentiate for understanding purpose A, A1, A2. All are same point only. So between A2 and D, one more capacitor, that is C2, is available. This is C2. Okay, so between B and D, one more battery. Now the circuit is easily you can understand, right? The previous is complex, now it's simplified. In this circuit, 3 closed loops are available. This is one closed loop, this is second closed loop, this is third closed loop. Clear? So using the first closed loop, I can identify the current, okay, because this is 2R resistance, this is R value of resistance, battery is available. So from the positive plate of the battery, the current will flow. So I can mark the current. So consider I current flow from the positive plate of the battery. So when it reaches this junction, right, it does not flow through the capacitor. Why? Because in steady state condition, the capacitor is open circuit. Clear? So the current doesn't flow through the capacitor. So it flow through the resistance R. Okay, it flow through the resistance R. When it reaches this junction point, again it doesn't flow through the capacitor C2, because in steady state condition, capacitor C2 is also open. So steady state condition, capacitor is nothing but open circuit. Okay, so current flow through this direction only. This is I. Okay, for this loop 1, I am applying a KVL law. So minus 2Ri. Okay, based on the direction of battery, okay, current flow direction of battery, minus 2Ri, okay, minus R into I plus E equal to 0. So from the loop 1, from loop 1, apply KVL law. Okay, so after simplification, E equal to 3Ri. So I equal to E divided by 3R. Clear? Okay, this is from loop 1. Clear or not? Next, I am not choosing the mesh, I am choosing the different loop. So many more loops are available in the given circuit. So for finding C1 divided by C2, I can consider loop so I can consider this loop. Start from A, A1, A2, D, this battery E, B, again it reach A. So this loop I can consider. Using this loop, I can write the equation, that is loop name is A, A1, A2, D, B, again A. So from this loop, write the KVL equation, right? So minus 2Ri. So this is the loop flow direction, right? So start from A, A1, A2, D, B, again it reach A. So it start from A and ended with again A. So this is the loop flow direction. Clear? So as per the loop flow direction, minus 2Ri minus 2Ri. Okay, next capacitor C2 is available. So in terms of voltage, we know very well Q is equal to CV. Q is equal to CV. Okay, because here I am writing the KVL equation. So what is V? V is nothing but Q divided by C. Okay, so here C2 is available. So I can write Q2 divided by C2. Q2 divided by C2, because the capacitor C2 stores the Q2 charge. So Q2 divided by C2 is nothing but voltage. This is nothing but a KVL equation. So we can write in terms of voltage only. The first term is nothing but minus 2Ri. This is one of the voltage drop. The second term is also we need voltage only. So in terms of Q and C, we can write the voltage equation. So second term is Q2 divided by C2. This is also one of the voltage drop. Okay. Then in this loop, the another element is battery, that is E. Okay. So the direction as per the loop flow direction, this is plus E. Okay, equal to 0. And one more thing is important, right? Check here I mentioned I, right? But the current I direction is just opposite to the loop flow direction. So this is the loop flow direction, but I direction is just opposite to the loop flow direction. So here I mentioned minus 2Ri, right? So what happened? The I direction is opposite to the loop flow direction. So this is also minus, right? So minus into minus plus. So this is 2Ri plus 2Ri. Okay, this is plus 2Ri minus Q2 divided by C2. Okay, plus E equal to 0. So this is the second loop equation, and I can consider this is the loop flow. Okay, so I consolidate both the equation in the next slide. Okay, so from loop 1, determined I value. So I is nothing but E divided by 3R. Clear? Okay. From loop A1, A2. Okay. Next DBA. Okay. The equation is 2Ri minus Q2 divided by C2 plus E equal to 0. Okay. But the question is, find the relation between what is the value of C1 divided by C2, right? So in both the equation there is no C1 term. So consider one more loop. Okay, so again I draw the circuit here for understanding. Okay, this is 2R, this is R, between this is the battery. Here battery is available, and here one capacitor, this is the capacitor, and here one more capacitor. Okay, and finally here another battery. So this is the given circuit. So 2R, R, C2, C1, E, this is also E. Okay. So this is A1, A2, C, B, this is D. Okay, A1, A1, A2, D, B, A. So I am considered this outer loop, right? So as per the outer loop, the equation is 2Ri minus Q2 divided by C2 plus E equal to 0. But in both the equation, right, this is equation number 1, this is equation number 2. In both the equation, the C1 capacitor is not available. So I can take one more loop equation, that is, I can consider loop BCD, loop BCD B. Okay, so if I am consider this loop, C1 capacitor is available. So from loop B C D B, okay, apply KVL law. So based on the loop flow direction E, okay, so for passive element we can consider the negative sign. So current entering terminal is positive, leaving terminal is negative, so it is nothing but voltage drop. All the passive element create a voltage drop, that's what we can consider the negative sign. So minus, in terms of the capacitor we can consider in terms of voltage because this is a KVL equation, no. So Q1 divided by C1, okay, so Q1 divided by C1, because we know very well Q equal to CV, so V equal to Q divided by C. So in KVL equation I can write the voltage drop. So voltage drop across the capacitor C1 is Q1 divided by C1. Okay, so again another battery is available, that is E equal to 0. This is the third equation. I think now you clearly understand, right? So from the loop 1, identify the current I, so I equal to E divided by 3R. Okay, then the outer loop I can consider A, A1, A2, D, B, A. Using this loop, calculate, apply the KVL equation, then this is in terms of Q2 divided by C2. Clear? Then, but in both the equation there is no C1 term, but question is find the ratio between C1 divided by C2. That's what I consider one more loop, that is BCDB. So from the loop, the equation is apply KVL law, E minus Q1 divided by C1 plus E equal to 0. Okay, so now simplify the equation 2 and 3. Clear? So here 2E equal to Q1 divided by C1. Okay, so Q1 C1 is nothing but 2 times of battery voltage. Clear? So this is, we can consider the fourth equation. Okay, so now from the second equation Q2 divided by C2 equal to 2Ri plus E. Okay, Q2 divided by C2 equal to 2Ri plus E. Okay, we can consider this is equation number 5. Now in the next step, using the equation number 1, 4 and 5, try to find the ratio between C1 divided by C2. Okay, so very first equation, I is equal to E divided by 3R. This is equation number 1. Clear? Next, 2E equal to Q1 divided by C1. This is equation number 4. Clear? The next one is Q2 divided by C2 equal to 2Ri plus E equal to Q2 divided by C2. This is fifth equation. Clear? Now substitute the equation 1 in equation 5. Substitute equation 1 in equation 5. 5. Okay, I'm going to substitute the I value here. Clear? Okay, so 2R, clear. What is I? I is E divided by 3R. E divided by 3R plus E equal to Q2 divided by C2. Okay, so this R, here another R, cancel. So finally 2E divided by 3 plus E equal to Q2 divided by C2. So after simplification, 3 is common, 2E plus 3E equal to Q2 divided by C2. So 5E divided by 3 equal to Q2 divided by C2. Okay, so this is equation number 6. Clear? So 5E divided by 3 equal to Q2 divided by C2. Okay, now compare equation number 4 and 6. Compare equation 4 and equation 6. Okay, so from equation 4, right? From equation 4, 2E equal to Q1 divided by C1. From that, find what is E. E equal to Q1 divided by 2 times of C1. Okay, so this is, we can consider equation 7. Now substitute this value into equation number 6. Okay, I can substitute the E value in equation 6, then only create the relation between C1 and C2. Okay, so now E equal to Q1 divided by 2C1 and 5E divided by 3 equal to Q2 divided by C2. Clear? So next relate equation 6 and equation 7. Okay, so what is equation 7? E equal to Q1 divided by 2C1. This is equation 7. So what is equation 6? Equation 6 is 5E divided by 3 equal to Q2 divided by C2. Okay, substitute the E value. Substitute the E value in equation 6. Okay, so 5 by 3 into Q1 divided by 2C1. Okay, equal to Q2 divided by C2. So the next step, 5Q1 divided by 6C1 equal to Q2 divided by C2. Okay, the problem itself, they clearly mention so check the problem. The energy stored in the capacitor C1 and C2 are same. Okay, energy stored in the capacitor C1 and C2 are same. So based on this statement, right? Okay, so based on this statement, Q1 equal to Q2. Why? Because we know very well the kinetic energy equal to half CV square. Okay, so half into CV into V. Okay, what is CV? CV equal to Q. CV equal to Q. Clear? So this is half Q V. Okay, so kinetic energy of both the capacitor we can consider. So for example, this is kinetic energy for capacitor 1, so Q1 into V. So kinetic energy of the second capacitor KE2 equal to of Q2V. Okay, so as per the problem statement, both the energies are same. Kinetic energy 1 equal to kinetic energy 2. Okay, so of Q1V equal to of Q2V. Okay, so here the term of V cancel. So finally the problem statement tells Q1 equal to Q2. Okay, so this is the given condition, Q1 equal to Q2. Clear? So what is the next simplification? So as per the problem statement, the Q1 and Q2 same value, so this is cancelled, right? Q1 Q2s are same. Okay, so finally, so that is 5 Q1 divided by 6 is 6C1. 6C1 equal to Q2 divided by C2. Here the Q1 and Q2 is cancelled, so 5 divided by 6 C1 equal to 1 divided by C2, right? So 5 by 6 is equal to C1 divided by C2. So this is the final answer. The ratio between C1 divided by C2 is 5 by 6, but the multiples of 5 and multiples of 6, 25 divided by 36 is also C1 divided by C2. Okay, so check the option. So here the option is A is 25 by 36, B is 1 divided by 36, C is 4 by 9, D is 9 by 4. So here the option is A 25 by 36, because 5 divided by 6 is equal to C1 divided by C2. So the multiples of 5, multiples of 6 they given. So 25 divided by 36 is the final answer. Okay. Thank you.